Hey there, fellow designers. Welcome back to my channel where I bring you the best CAD modeling tutorials. Today, I'm going to walk you through the process of designing a universal joint design from scratch. Universal joints are essential components in many mechanical systems, and mastering their design will level up your CAD skills. So let's dive right in. Before we start modeling, let's quickly go over the basics of universal joints. A universal joint, also known as a U-joint or Cardan joint, is a mechanical connection that allows two shafts to rotate at different angles while transmitting torque. They're commonly used in automotive applications such as drive shafts and steering systems. A typical universal joint consists of two yokes and a cross-shaped component called a spider. Now that we have a basic understanding of universal joints, let's set up our CAD environment. I'll be using Onshape for this tutorial, but feel free to use your preferred software. First, create a new project and set the units to millimeters. We will start by designing the spider component. If you're enjoying this content and want to see more, make sure to hit that like button, subscribe to my channel, and click the notification bell so you never miss an update. Share your thoughts in the comments below and let's keep growing together. Okay, so I will stop the animation of this assembly with two universal joints, and we'll show you the part studio. And so we got three parts. The spider sphere, I'll hide those. So that's our spider. That is our yoke. And then some disc. Okay. Let me take this over here. And let's start with that spider sphere and an empty part studio. So I'll take that top plane or that front plane to draw a circle. I press N to the normal view at the front plane, P to hide the planes. Start at the origin, draw one line across here. With M, I cut the circle. With D, I dimension that circle to 44 radius. Then another circle from the origin with a dimension of 24. All right. Let's go into the revolve command. Take that face, that one, pick that axis. All right, so we got a sphere. Then let's extrude our small circle. I show the sketch and go into the extrude command, hover over my sphere, press right click, select other, and take that face. Do it once more for the bottom part. And then type in 82 for the dimension. Let's have a look at that. All right. And give that a chamfer, 4 millimeters of that edge. All right, let's rename our part here. Spider sphere. And some appearance change, maybe that. And let's define one plane with an offset from that face and that direction 16 millimeters. And let's start a sketch on that plane. Press N. Press U to project that edge of that chamfer and that one. Okay, that's it for the sketch. Let's have a look. Here it is. And let's extrude that with a 12 millimeter. I just picked the sketch here, sketch 2, remove, type in 12, symmetric, accept that, there it is, hide that plane. And now we get those 3 features for that part. Let's make a circular pattern of features. Pick extrude 1, chamfer 1, extrude 2. Axis is this. Hide that plane. And our first component is ready. So we got our first part, the spider sphere. And let's continue with the yoke. So for that, I take the top plane. Well, let's see. I want to keep that sketch number 2 visible. And yeah, I take the top plane, start sketching on that, and normal view to that. And now let's draw a line. I'll sketch it over here so you see what's going on. Give that a midpoint relationship between that line and that point. Dimension is 28. Go into the center point arc command here. Take that center, connect it here to our line. Go down here, vertical constraint, and one rectangle really. From here, like this. And the dimension of that rectangle, let's dimension that to the origin with 222. And a width of 12. Accept that. And now I'll show it like this. Hide the sphere for a moment, hide that sketch number 2. Let's extrude that with the thin feature. So I go into extrude, thin, take that edge and that one, make that 6 in that direction, 6 to the other one, at a depth of 28, and that'll be symmetric. Accept that. Keep the sketch visible. Look at the sphere. Then give that a full round. Here, take that face, that one, and that one. Rename that yoke and make it yellow. Okay, and sure, that part needs that hole here. For that, we use the Boolean operation for multi-body modeling, subtracting. So that is our tool, and that is our target. We keep the tool, and now, see, that's what we want. Now we mirror that part over that face, accept that, and with the revolve of the shaft, we will unite those bodies, revolve, take that axis, add to that one, and that one. Accept that, and now we just got one yoke. All right. So, next is just a disc to attach our yoke to. So we take that face here. We can hide that sketch here, sketch 3. We take that face, say sketch, N, U to project that edge. Make a circle with that same origin and dimension that with, let me have a look at my part here, 122, 122, and extrude that here, not with as a solid, go into the other direction with 18 millimeters as a new body. Accept that and give that some chamfer here, there and there. Call that body disc, and I'll give some green color to that. Yeah. All right, and that's everything we got to do in the part studio. Really, we're finished with sketching, with modeling, and next is the assembly. All right, so let's get in there, and I will define one mate connector with the origin, and I want the z-axis pointing towards me, so I will rotate that around the x-axis with 90 degrees, like this. That's the first one. And now let's insert the complete part studio here and tear that apart. And I will start with a fastened mate between that edge and that one. Go in the other direction. Oh, we'll work in that direction here. Okay. Let's have a look. There. I'll be building this up here to the left. So next is our yoke with a revolve mate. Take that and take that one. Okay. Let's have a look what that does here. Animate. There it is. That's what we want. And now let's make another revolute mate between that edge and that one. Turn that around, accept that, and exit that, move that a little so there's no collision. So now let's define that other mate to connect our second group. I go into mate, take that same origin, and now let's see, move that one, and in the Y axis, let's take that minus 644, and in the Z axis, let's take that 288. There it is. And now let's rotate around the X axis with a 90 degrees. Can turn that around. Hey, no, I didn't want that. Keep it there. We'll keep it there. All right, and now insert one more part studio here. Take that apart. Apply a fastened mate between that one and that one. Okay. Revolute mate between that one and that one. And another revolute between that one and that one. Turn that around. All right. And now let's connect those two spheres here. For that, we insert a yoke, two yokes, apply the revolute between that edge and that one, like this, and between that one and that one. Okay. Let's exit that for a moment. Turn those pointing towards each other. Here, here, and finally, let's apply a slider mate between those two. So the slider mate is here. Pick that cylindrical face here. Pick that. Accept that. And then let's go into the first revolute mate. Right click, animate in a loop, press play, and there is our universal joint. Well, two of them, right? I hope you like that, and I see you in the next video.